Okay, so in this example, we have a real zero here at x equals -3, and that is a bounce, so that's going to have multiplicity of 2, right? Because bounces have even multiplicity, and since we want to write the polynomial of least degree, the lowest even number is 2. And then our next real zero we see is here at the origin, so x equals 0, and that is a cross, so it does not have multiplicity. The factor would be linear. Okay, then we have the end behavior to consider, and this graph is up on the left and down on the right. So the leading coefficient test tells us that it has an odd degree and that the leading coefficient is negative. So when I go to write the equation of this polynomial, I'll have y equals a negative because of the leading coefficient test. Then I need a factor of x plus 3 because of the real zero here at -3, and it needs to be multiplicity of 2. And then to get this cross at the origin, I also need a factor of x, and that's a linear factor. So when you write polynomials, generally if you have an x by itself, that would be in front of the binomial, so we could rewrite that then as -x times the quantity x plus 3 squared. And that would be the factored form. Now to get that into standard form, we have to expand this polynomial. If you remember the shortcut from Algebra 2 for perfect square trinomials, this binomial squared would be x squared plus 6x plus 9. If you're a little rusty on Algebra 2, we can FOIL it out to expand. So this would be an x plus 3 times another factor of x plus 3. And then when we FOIL, right, we do first, outer, inner, last. So x times x is x squared. Then x times 3 is plus 3x. Then we have 3 times x is another plus 3x, and 3 times 3 is plus 9. So you can see then the middle here is always double when it's a perfect square trinomial, so that's going to combine then to be 6x plus 9 in the middle. Okay, then we have to bring down that factor of -x that we had in the front, and then we're going to distribute the monomial times the trinomial to get rid of the parentheses. So -x times x squared is a -x cubed. Then -x times 6x is a -6x squared. And then we have a -x times a positive 9 is a -9x. And that would be the polynomial in standard form that produces this graph. So when you compare this with the answer that got typed in, you'll see that your coefficients were all the wrong sign, right? Because you didn't account for the end behavior of the graph. So this should have been a -1 as your coefficient on x cubed, a -6 as the coefficient on x squared, and then a -9 as the coefficient on the x. So then in the next example, we wanted to write the polynomial in standard form, least degree, positive leading coefficient. The zeros are plus or minus 4, so that's a factor of x minus 4 and a factor of x plus 4. And then 2 imaginary zeros in this conjugate pair, so we have x minus I and x plus I. Okay, and it doesn't say that any of those factors have multiplicity, so we don't need to worry about that. Okay, when we go to put this into standard form, x plus 4, x minus 4, that's a difference of squares. So we can use a difference of squares shortcut, and we'll get x squared minus 16. Okay, then this x plus I, x minus I, this is also a difference of squares. And so the shortcut for difference of squares from Algebra 2, that would be x squared minus I squared. And I squared, if you remember from Algebra 2 with your imaginary numbers, is the square root of -1. And when you square a square root, the inverse, right, cancels out the square root. So I squared is just -1. So I can replace this I squared here with a -1. And x squared minus a -1 would be x squared plus 1. So this will be x squared minus 16 times the quantity x squared plus 1. Okay, then we have a binomial times a binomial, so we're going to FOIL. So first, outer, inner, last, x squared times x squared is x to the 4th. Then x squared times 1 would be a plus x squared. Then we have -16 times x squared, so -16 x squared. And then -16 times +1 is a -16. Then we'll combine our like terms in the middle, and we have an x to the 4th power. And then these are both x squareds. So 1x squared minus 16x squareds would be a -15x squared. And then our constant is a -16. So when you compare that answer in standard form with what was typed in up here, the coefficient on x to the 4th is correct. That's a 1. But then in the middle, this should be a -15x squared, and then the constant should be -16. Okay, in the third example, we've got let's see, zeros of plus or minus 6. So that's a factor of x plus 6 and x minus 6. And each have multiplicity of 2. So each of those is going to be squared. Okay, so now when I go to expand this, I have a difference of squares again, but 2 of them. So when I use that difference of squares shortcut, I have x squared minus 36, but because there's 2 difference of squares, then that's still a square on the outside. Okay, then this would be a perfect square trinomial. So if you remember your shortcut from Algebra 2 for perfect square trinomials, we would square the first term, so x squared times x squared is x to the 4th. Square the last term, which I need a calculator to square 36. So 36 times 36 is 1296. So that'll be a plus 1,296 on the end. And then in the middle, we multiply and double. So 36 times 2 is 72. So -72x squared. Okay, so that would be the polynomial in standard form. If you don't remember the shortcuts for the difference of squares and the perfect square trinomial, right, I'll show you how to work those out the long way. So if you have an x plus 6 and an x minus 6, and you FOIL, right, x times x is x squared, x times -6 is -6x, 6 times x is +6x, and 6 times -6 is -36. And see in a difference of squares how the middle terms here, the oi in FOIL, the outer and the inner, those always cancel out, right? And you'll just be left with the first term squared minus, and then the last term, so difference of perfect squares. Okay, that's how I did the difference of squares shortcut. And then since each of these were squared, then my resulting binomial was squared. Okay, the perfect square trinomial that we had here, change colors so you can see that. So if I expand that the long way instead of using the shortcut, x squared minus 36 times another x squared minus 36. Right, we would FOIL, so x squared times x squared is x to the 4th. That's squaring the first term. Then the first outer x squared times negative 36 is negative 36x squared. Okay, then the inner is another negative 36x squared. And then the last would be negative 36 times negative 36, which is positive 1,296. So that shortcut that I did for the perfect square trinomial is you square the first term, so x squared is x to the fourth. You square the last term, that's your 1296. And then to get this middle term, this negative 72x squared, right, notice that the middle here, the oi in FOIL, those repeat. So I would just take my, my first and last, multiply them, and double it. So negative 36x doubled is negative 72x, or x squared, sorry, in the middle there. So that's the difference of square shortcut and the perfect square trinomial shortcut. So if you want to do the algebra out the long way, you certainly can, or you can use those shortcuts.